Okay, you are welcome back to the Introductory Mathematical Analysis A. And again, we are still in Chapter 7. In Chapter 7, we are able to cover the linear inequalities. The linear inequality. Also, we are able to cover system of linear inequality. Systems of linear inequalities. Alright, we continue with it by going into linear programming proper. Okay. The knowledge of how to draw the graph for a single inequality of single linear inequality and how to draw the graph for systems of linear inequalities especially will be used here. Okay, linear programming. What is linear programming? Linear programming is the tool used to determine the maximum or minimum value of a function. So it's a tool, mathematical tool, used to determine the maximum or minimum value of a function, subject to certain restrictions, certain constraints. Okay, on the domain of the function, So in linear programming, first we have what we call the objective function. So we are going to be dealing with first the objective function and the constraint. So we have two things. A linear programming has two parts, objective function and then the constraint. Objective function and then the constraints. Okay, the constraint are the linear inequalities we were able to draw the graph for previously. So we are going to be using that knowledge for the constraints. And then we are going to be using from our graph, determining from our graph what will be the value of x and y to make this objective function maximum or minimum. Okay. Note that the maximum or minimum will always be one of the corner points in the visible region. Okay, we learned about visible region the other time. So we are going to also be getting the corner point from the visible region, and the maximum or minimum we are looking for will be one of the corner points. Okay. All right, let's go. Now, this is an example of a linear programming problem. We have maximize this objective function subject to these constraints. All right, sometimes we will be asked to minimize. Okay, you'll be asked to minimize. Okay, so when we mention the word optimize, let me use this opportunity to mention this. This optimize means either to maximize or to minimize. It is either to maximize or to minimize. So if you are asked to find the optimal value, so we are either looking for the minimum or the maximum depending on the problem. Okay, so that word optimal means for both minima or maximum. Okay, so this is a typical example of a linear programming problem. This is the objective function which we are going to be looking for. This is the constraint which we are going to be drawing graph for. The graph we drew for systems of linear inequalities, we are going to be drawing in it for this one, and then use the corner point here to determine what is this one. Okay, in a real world problem which we are going to be solving, these two constraints, they are very important. S greater or equals to 0, y greater or equals to 0. We call them non-negative constraint. Non-negativity constraint, yes. So they are very important. So sometimes we write it like this, sometimes we'll just write it y comma x, s comma y greater or equals to 0. So it means this. These two means the same thing. It is either you write x comma y greater or equals to 0, or we write x greater or equals to 0 and then y greater or equals to 0. They mean the same thing. Okay, so this is an example of linear programming problem which we are going to be solving. Sometimes we give you the word problem for you to get out this linear programming formulation. We call this linear programming formulation or linear programming model or linear programming mathematical formulation. So this is for linear. So sometimes we give you the problem in Word, which we are going to see later, and then we ask you to formulate this linear programming for yourself or by yourself. We ask you to formulate this out and then solve. But sometimes also we just give you this formulation and ask you to find the solution. And how do we do that? You do that by graphing this graph of the inequalities and then use the corner point here to get this one. Okay, we'll quickly do this one so that you can have understanding of what is being done. Okay, we'll do this one. Okay, all right, so let's go into this example. This is our constraint. Don't forget, this is our objective function again. This is our objective function. We call it objective function. Okay, and this is the constraint. These are the constraints. All right, so to draw our graph, we draw graph for these linear inequalities. That is for the constraint. So let's go by drawing graph for this constraint. All right, this constraint, let me label this constraint. So I have this one as 1, I have this one as 2, I have this one as 3, I have this one as 4. Okay, those are my constraints. Okay, so the way we did the other one, for the first constraint, the equation of the first constraint, the equation for inequality 1, the equation for inequality 1 is x minus 4y equals to minus 8. Okay, that is the equation for inequality 1. So here, when x is 0, y will be what? Y will be 2. When y is 0, then x will be minus 8. Okay, that is for inequality 1. Now the equation for inequality 2 is this one. Here again, when x is 0, y will be 8. Okay, and then when y is 0, x will be what? Will be 16. Okay, now for inequality 3 and 4, the equation for 3 is just x equals to 0. Okay, and then we'll be shading the one that is greater. The equation for inequality 4 is y equals to 0. That is the equation for inequality 3 and inequality 4. Okay, let's draw our graph. So take note of the fact that the highest value of y is 8, positive 8, and the highest value of x is positive 16. We also have negative 8 on x, so take note so that you can know how to draw the graph properly. We have positive, so this is x, We have negative 8, okay, fine. All right, so we can draw like this, and then this is my y. Okay, this is x, this is y. Okay, this is 16, this is 8, so I can take 2, 2, 2, 4, 6, 8, 10, 12, 14, and then 16. Okay, this will be negative 2, negative 4, negative 6, negative 8. Okay, for y, the highest is 8, and okay, 2, so we can have, you can also have it as 2, 2. You can also have it as 2, 2, negative 2, no, positive now. And this is 4, this is 6, this is 8, okay. This is negative 2, this is negative 4, okay, we can stop there. All right, so let's go. So for this one, when x is 0, y is 2, y is 2, y is 2, y is 2. And when y is 0, x is minus 8, minus 8, okay, I didn't write this one. Minus 8, okay, we have minus 8. Okay, let's look, maybe it's a dotted line or a solid line. Don't forget that also. This is a solid line, this is a solid line. Okay, don't forget that. They are both solid lines. Okay, so I draw a solid line here. Okay, it must be a straight line. Okay, so now I need to know where to shade. In order to get where to shade, I pick 0, 0, and I put it into my inequality as we have done before. Don't forget that. That will be 0 minus 0 less or equals to minus 8. 0 less or equals to minus 8. Is this true or false? This is false. This is false. Okay, because it is false, where I pick here is the wrong side. So now I need to determine, should I shade the correct side or I should not shade the correct side? You need to determine that. Okay, now I just decide to shade the correct side. I decide to shade the correct side. Okay, I'm shading the correct side. I'm shading the correct side. I'm shading the correct side. Don't forget, you can decide to shade the correct side or not. And that must be done for all the inequalities. Okay, no, I'm using red. Okay, shade the correct side. That is for the first one. Let's go for the second one. When x is 0, y is 8. When x is 0, y is 8. Y is 8. When y is 0, x is 16. X is 16. X is 16. X is 16. Okay, again, another solid line. Solid line, solid line, solid lines. Okay, let's determine where to shade again. I pick 0, 0. I put it into this inequality. I'm going to be having 0 plus 0. 2 times 0 is 0. Less or equals to 16. 0 less or equals to 16. 0 less or equals to 16. 0 less or equals to 16. Is this true or false? This is true. So I'm shading the side of the point I pick. I pick 0, 0 here. So I'm shading this side because that is true. So I'm shading this side because that is true. I'm shading this side because that is true. I'm shading this side because that is true. Okay, the next one is for us to find the graph, the line of s equals to 0. What is the line of s equals to 0? The line of is this line. The line of s equals to 0 is this line. S equals to 0 is this line. So I need to shade because the inequality says s must be greater than 0. This side is greater than 0. This side for s is less than 0. So I'm shading this side. I'm shading this side. Don't forget I'm shading the side of my solution. Don't forget that. If you decide not to shade the side of your solution, you must do the same thing for everything. I'm shading the side of my solution. I'm shading the side of my solution for x greater than 0. Okay, the next one is for us to determine y equals to 0. The line y equals to 0 is this line. Y equals to 0 is this line. Okay, y equals to 0, that is the line here. Okay, now I need to shade the side of y greater than 0. I need to shade the side of y greater than 0. This is the side of y greater than 0. Let me use another color. This is the side of y greater than 0. Okay, this is the side of y greater than 0. Okay, this is the side of y. Don't forget again, I'm shading the correct side. I'm shading the correct side. All right, from our shading now, you will discover where we have the intersection of everything. The intersection of everything is this side. This one, this one, this one, and this one. So the corner point is this one. This is the corner point. Okay, those are our corner point. Our corner point is that one. Our corner point is that one. This one, and this one. Because this is now our visible region. This is our visible region. In this line, we shade like this. In this green one, this other line, let me label the line. That is 1. This is line 1. We shaded this side. This is line 2. Okay. We shaded this side. We shaded down like this. Line 3 is this one, the one for x equals to 0. And we shaded like this. And then line 4 is this one. This is line for y equals to 0. And we shaded up. This one we shaded this side. We shaded our right. In 3 we shaded our right. In 4 we shaded up. So this now brings our visible region to this point. So now we need to find what is each of these corner points, because we want to determine, don't forget, we want to determine what is the maximum. So we need the corner point first. So what is this corner point? This is 2 and what? When x is 0, y is 2. So one corner point, I will label the corner point now. Let me label the corner point as A. This is a corner point A. This is another corner point B. This is another corner point C. Okay, that's our corner point. A, B, and C. Alright, so the corner point for A, is simply 0, 2. When x is 0, y is 2. Okay, that is fine. Corner point for B, what is the corner point for B? Is 0, 8. When x is 0, y is 8. That is corner point for B, 0, 8. What about corner point for C? Corner point for C, do we know the corner point for C? But the corner point for C is the intersection of these two lines. Okay, that means the corner point for C is the intersection of this line and this line. So we can just equate it together and solve for x and y. Okay, so we want to determine the corner point for C by solving x minus 4y equals to minus 8, and then x plus 2y equals to 16. Okay, in order to get the corner point for C, we need to solve this. In order to solve this, I can just minus because this is x, this is x. So this will be minus 4 minus 6y equals to minus 8 minus 16. Okay, that will give us minus 24 minus 24. So y will now give us 4. Y is 4 on that one. Then to get what is our x, put y equals to 4 in any of this equation. So x minus 4 times 4 equals to minus 8. X minus 16 equals to minus 8. And then we have x equals to minus 8 plus 16, which is equals to 8. Okay, so that means the point of our C, is 8, 4, 8, 4. That is the point of our C. All right, we need to put each of these points into the objective function, put each of the points into and see which one will give us the maximum. Which one will give us the maximum? So let's try to put, so don't forget we are maximizing. Maximize. So we are looking for the maximum. Z equals to, what is that one now? Maximize Z equals to 2x plus 4y. Okay, let's put each of these points and see which one will give us a maximum. Which one will give us a maximum? Which one will give us a maximum? Okay. All right. Putting A02. Which one? Z will now become, what will be Z? 0 plus 8. So Z equals to 8. Putting B, which is 0, 8. Then Z becomes 0 plus 4 times 8. 4 times 8 is 32, which will give us 32. All right. Putting C equals to 8, 4. Then we have our Z to be 2 times 8 is 16, plus 4 times 4, 16. Okay, that's fine. So 4 times 8 is 32, okay, right? So that means that will give us also 32. 2 times 8, 16. 4 times 8, 16. That will give us 32, okay? So here now we see the second one. This is 0, 4 times 8. That is 32. That is fine. So we see this one and this one give us the same thing. So in this case, we have multiple solution. So the maximum is this, either at this point or at this point. So the maximum is 32, but at that maximum, we have x equals to 8 and x equals to 4, or x equals to 0 and x equals to 8, y equals to 4, or x equals to 0, y equals to 8. So at this point, where is that point now? Yes, this point now. So take note, this one and this one gives us the maximum of it. Okay, so there are multiple solutions. This line, any point of this line gives us a solution. Any point on these two lines, any point on that two lines gives us a solution. Okay, so the maximum is at, we are max Z at, the maximum is at 32. X could either be 8 and y 4, or x is 0, y 8. Any one of them give us the maximum we're looking for. Okay, that is how to get the maximum. That's how to solve a linear programming problem, given a linear programming problem like this. Okay, I hope you understand. Please ensure that you are able to understand.